Hello! Today I'm going to explain about isomorphism graph. Isomorphic graph is when there is a one-to-one correspondence between their vertices and edges such that incidence relationship is preserved. If the two graphs is isomorphic to each other, we can write as below. The condition to check the isomorphism is condition 1, same number of vertices. Condition 2, same number of edges. Condition 3, equal number of vertices with same degree. And the last one, condition 4, same degree sequence and cycle vertex. Example: which of those graphs is isomorphic? Solution: in the graph G3, vertex W has only 3 degrees, whereas all the other graph vertices has 2 degrees. Hence, G3 is not isomorphic to G1 or G2, so G1 is equals to G2. Now you know the basic of the graph isomorphism. Now get ready for the next lesson. Isomorphic graph questions. Show the following graph is isomorphic or not. First, label the graph with suitable labels. List down the adjacent details of each vertices in graph 1 and graph 2. Compare the info from these two graphs. Answers: the two graphs are not isomorphic because the adjacent of the point F in graph 1 is not similar as in the graph 2. Now I will show you another example of graph isomorphism. Which of the following graphs are isomorphic? For any two graphs to be isomorphic, following 4 conditions must be satisfied. First, number of vertices in both the graph must be same. Second, number of edges in both the graph must be same. Third, degree sequence of both the graphs must be same. And the last one, if a cycle of length k is formed by the vertices in one graph, then a cycle of same length k must be formed by the vertices in the other graph as well. Solution: condition 1, number of vertices in graph. Here, all the graphs G1, G2 and G3 have the same number of vertices, so condition 1 is satisfied. Condition 2, number of edges in graph. Here, the graphs G1 and G2 have the same number of edges. So, condition 2 satisfies for the graph G1 and G2. However, the graph G3 have different number of edges. So, condition 2. Since condition 2 valids for graph G3, so they cannot be isomorphic. G3 is neither isomorphic to G1 nor G2. Since condition 2 satisfies for the graphs G1 and G2, so they may be isomorphic. G1 may be isomorphic to G2. Now, let us continue to check for the graphs G1 and G2. Condition 3. Degree sequence of graph. Here, both the graphs G1 and G2 have the same degree sequences, so condition 3 satisfies. Now, let us look at condition 4. Both the graphs contain two cycles, each of length 3, formed by the vertices having degree 2, 3, 3. It means both the graphs G1 and G2 have same cycles in them. So, condition 4 satisfies. Thus, all the 4 necessary conditions are satisfied, so graphs G1 and G2 may be isomorphic. Now, let us check the sufficient condition. We know that two graphs are surely isomorphic if and only if their complement graphs are isomorphic. So let us draw the complement graphs of G1 and G2. Therefore, graph G1 and G2 are isomorphic graphs. Algorithm and applications of graph isomorphism. Graph GA and GB are said to be isomorphic if their vertices can be rearranged so that the corresponding edge structure is exactly the same. To show that graphs GA and GB is isomorphic, it suffices to find one such rearrangement of vertices. Types of algorithm for graph isomorphism. The exponential worst-case time complexity is the best known algorithm to find out whether two graphs are isomorphic or not. A public domain program called NAUTY algorithm can determine whether two graphs are isomorphic in less than a second. Applications of graph isomorphism. Chemists use a molecular graphs to represent chemical compounds. Vertices represent atoms and edges represent chemical bonds. Electronic circuits are modeled as graphs in which the vertices represent components and the edges represent connection between them. Graph isomorphism decides whether a chip from one vendor includes the intellectual property of another vendor.
Just